All right, great. We're recording. Okay. Hey, it's Joe Burnett. I'm here with Zeph. We're going to talk through the Fleeting and Taskscaler test plan. This is a draft of like how to test this new system. First, I'm going to start by giving kind of a real quick down and dirty overview of what Fleeting and Taskscaler is, so we are on the same page. And then we're going to walk through this thing, and we don't actually really have an agenda. We just wanted to get together and talk about it. So we'll just see what comes. So yeah, Zeph, you wanted to know about Fleeting. What is Fleeting? So there's a couple things that we've been wanting to do in Runner. One of them is to pull it apart a little bit so we can have more modular components so that we can handle more use cases more easily. We also want to be able to have smaller components so we could test them more easily and change them without breaking everything. And we also want to replace Docker machine. So the approach that we've taken with Fleeting and Taskscaler is pulling out two things that lets us replace Docker Autoscaler and gets us a few new use cases. So Runner here talks to GitLab, right? And it makes a call to GitLab and it starts following for jobs, it says, give me jobs. What used to happen is we used to actually like have this library Docker machine, which would kind of create, remote instances, and it would run Docker inside of there. And then you could run a Docker container. And this was a specific executor, right? Docker machine. So, and it was a specific library as well. And you had to have like all the details about like the cloud provider and everything. So there was a lot, and it was the only real like auto scaling executor. So auto scaling was part of executor. It was only for Docker. You had to like have all the details about like whenever, a cloud provider like Google would add something, we would have to add it to Docker machine, and you would have to specify all that in the runner config. And Docker machine has been deprecated for some time. So there's a lot of things about it that made it difficult to maintain. So we are actually replacing this with a system called Fleeting. So what we've done, first of all, is we've taken out the auto scaling part and we've put it into this thing called Taskscaler. It's a separate library, so like we get a chance to sort of, we have a very clearly defined interface. We do shim it in there as an executor. There's one executor called instance, and there's an executor called Docker Autoscaler. And these use Taskscaler to autoscale the environment and either run something in the environment or run it in Docker. And Taskscaler actually is just the autoscaling part. The other thing that we pulled out is creating the instances. So that's called Fleeting. So say you have a cloud provider and they can create these instances like GCP, AWS, Azure, etc. There's this library called Fleeting that takes this group and puts it behind an instance group abstraction. So rather than like specifying exactly the dimensions of the machine, you just say, just give me an instance group. I'll tell you how many I need, so you can scale the size, you can get connection info, and you can delete it when you're done. That's like a really simple, straightforward interface. And as it is, the Fleeting plugins actually run in a separate process space, like it's a separate binary that starts up. And the reason that we do this is because when you write something in Go to connect to a cloud provider, you import all the stuff that they provide with their SDK, right? And in order to like have all the cloud providers, you would have to reconcile all of those dependency graphs. So that one reason to have it in a plugin is so that you can just have each one of these will have its own Go mod, right? The other reason to have it in a plugin is so that people can create their own plugins, right? Which will go to, I don't know, whatever cloud environment they want. All they have to do is implement this. So Fleeting gives us capacity, right? It gives us machines, right? And Taskscaler gives us auto scaling. The nice thing about these Fleeting plugins is you can actually swap them out very easily. Like the difference between Azure, AWS, GCP is usually just the name of the plugin, maybe a few different parameters like region versus zone or something, etc. The rest of it is set up out of band. Like in GCP, you have to create an instance group or an instance group manager. Which is where you specify what instance type. In AWS, you create, an auto scaling group, which we don't actually use for auto scaling, but it's just a way to have like a homogeneous group of VMs with a dial that you can delete from. So that is Taskscaler and Fleeting. Do you have any questions about this so far? Does this make sense?
Yeah, I think I was up to speed up to this level at least.
Okay, cool. All right. Yeah, so that, now, well, how do we test this? So let's talk about the testing plan. I'm going to pull this out here and share that screen instead. Let's see. All right, so this issue is under GitLab Runner. It's meant to sort of capture all the tests that we want to have. We've been building these ad hoc. Some of them to replace Docker machines. Some of them have been built as part of using Mac runners on AWS, which uses this AWS plugin and Taskscaler and Fleeting. So we're actually using this in production. There's a couple dimensions that change, right? Like setting up Run is complicated. It's like, what executive you want to use? What auto scaling parameters? Where do you want to run the manager? Where do you want to run the ephemeral jobs? Etc. There's a lot of dimensions, and so you want to be kind of careful not to get a combinatorial explosion. So this kind of like shows you here, we have different places that we can put runner, right? You can actually run runner in GitLab on runner. It's a ridiculous thing called runner incept. So this is one of our test cases. You can install it in GKE, GCE, etc. All these places you can put it. Like, for example, the shared runners are in GCE. Additionally, with this Fleeting plugin system and even Docker machine, you can choose where you want to run the actual jobs. We probably don't need to test like every cloud provider with every cloud provider, like just certain levels. There's the individual runner packages and Taskscaler, which are built into a single binary, as I mentioned. And then there's these individual binaries here. So like, we kind of want to get some testing in depth. So
Yeah,
what I've done first,
are we currently building those images? Or I was looking at the instructions and it mentioned having to compile the plugin yourself to get the binary
we've
to
been
install it.
releasing them, at least the AWS one is released. So
Okay.
for example, our runner incept test
Hmm.
just downloads the latest binary and then runs it.
Oh, okay.
Ultimately, we'll want to install them, with like we'll want to release packages too.
Hmm.
Probably like maybe individual plugin packages, but probably also a package that includes all the plugins. So you can just be like, give me all the usual ones and I'll just pick the one that I want. And they're all named Fleeting plugin, AWS, Fleeting plugin, Google Compute, etc. Yeah. So I've kind of tried to give some clarification about the different um, test types, just so we have a common language.
Hmm.
The first kind is the one I was referring to called incept test. It's it's what we do is we in a runner job. So like in our CI/CD pipeline, we install runner there in this job, have runner register itself to GitLab sort of like as a one-off, and then run a job using it. So we're running runner in runner. It's kind of like an end-to-end test, but it's not a very realistic scenario. So
Right.
I think they're worth keeping because it's a nice way to incorporate it into our pipeline. But I want to also have end-to-end tests that install things in a realistic environment.
Hmm.
Um,
Yeah, so
yeah.
that'll be something I want to get into with you is I contributed early on to Runner and Sept, but when you
Mhm.
get into your end-to-end and integration descriptions, I want to understand what you're thinking of environment-wise with those.
Sure, sure. Okay, all right. Okay. So end-to-end test. I want to, for example, create a cluster in GKE,
Hmm.
install the Helm chart, and install it. And when we configure, when we put runner in there, we can put it in with a plugin and give it credentials to another instance group. And so I'll create, in addition to creating, this cluster where we run the runner manager, I want to
Hmm.
point it at an instance group in Google that also creates VMs.
Hmm.
And then I want to run a job on it and verify that the whole thing works end to end, and then tear it down. That would be one end to end test. The end to end tests are going to be very simple um, in my mind because it's a huge amount of setup. Like it's a lot of pieces that you set up.
Hmm.
I'm more
Hmm.
interested in catching like pieces of the pipeline that don't match up. For some reason this thing stops working. It's like the very last line of defense.
Hmm.
Um, thoughts
Yeah,
on
that
that?
was the yeah. I had the same concept for end-to-end tests. That's part of why I was working on that runner staging project, right?
Yeah.
To do the
Mhm.
same, to do these deployments and actually hook them up to a functioning GitLab instance and
Yeah.
walk through some of these. But you mentioned keeping them as simple as possible. Yeah, these things get flaky for sure. How much are you wanting to? I mean, typically, if you follow the test pyramid, your end-to-end tests are the smallest little piece of it, right at the
Mhm.
top. Um, but are there things specifically that you've come across that you felt like would be great targets for end-to-end testing, other than just your basic business use cases, kind of top level?
Um,
Does it, can you run a pipeline? Does it complete, those types of things?
that's what I was thinking of. Is just
Hmm.
hello world, you know.
Yeah. Yeah. So more
Yeah.
sanity smoke level.
Yes.
Okay.
Yeah. Yeah. I think if there is a really important like business use case, we can start representing them here. But
Right.
I but our starting point should just probably just be a hello world.
Hmm.
Things like correct auto scaling decisions will be much less flaky and much easier to test down at the Taskscaler integration level with a dummy plugin where we don't
Okay.
have side effects. You wouldn't even have to set up a cluster at all to run
Hmm.
something like that. Um, it sounds like a lot of work to set all that stuff up. Um, there's another project called Grit, just for those. I know you mentioned I know you read it. I want to I wanted to just show it for anybody watching the video. The idea is it's the GitLab uh, Runner infrastructure toolkit, which
Yeah, which is
requires
awesome, I think.
some grit to make it work. And basically, I want to have a curated library of Terraform templates that does things like set up a cluster, install GitLab, make a fleeting stack, register it to the desired one, sort of like something that we can use for end-to-end tests, development, and even production. So like
Mhm.
the project is under here, Git Runner tools, grit. Right now, all it has is I can make a fleeting capable, auto scaling group that uses nested virtualization with Max on
Mhm.
AWS with auto scale, which is actually a lot of setup. Like if I was to do this from scratch by hand, knowing what I'm doing, it'll take me
Mhm.
a couple of days to set it up. So it's really nice to have this, like, because it requires licenses,
Mhm.
dedicated hosts and stuff, and you can just set this up with a command. So I'm hoping, like, when we get around to doing this, I'm hoping we can do it together, build the Terraform templates, and it'll just be like, actually the end-to-end test code is probably going to be pretty small.
Yeah.
It's going to be like, import this thing with these parameters, set up this stack, run this hello world job, you know.
Yeah, I think grit's going to be something fantastic. We had kind of talked about it a few weeks ago,
Mhm.
and I wasn't sure exactly where you were thinking of trying to put some of these templates, but putting them into their own project like this with its own toolkit to be able to do this, I think that makes perfect sense.
Yeah,
And it's
yeah.
very, very much like our Get setup, which I think I mentioned to you before, our GitLab environment
Yeah,
toolkit.
actually, that was kind of part of the inspiration. I was like, I want it to be kind of like Get. I'm intending for it to be production grade from the beginning, so I'm trying to like
Mhm.
steer as many use cases as possible into it. But yeah, that's the idea for
Yeah.
sure.
Then next steps for that, by the way, would be having the Get toolkit called Grit to take care of some runner installations so
Sure,
we can do some performance testing there.
totally, totally. Yeah. All right, so that's end-to-end tests. Can we talk about integration tests now?
Yes, please.
All right, so when I'm thinking integration tests, I'm just talking about like testing multiple units, but not necessarily, doesn't necessarily have to go over the network.
Mhm.
These are actually relatively small. So, okay, so first of all, to take a step back, these are a few additional inset tests we need just to sort of
Mhm.
make sure these plugins work. And these are some end-to-end tests that we'll create with Grit. But
Right.
moving down to integration tests, there's two things that I would like to, oops, I clicked on something. There's two things I want to test with integration tests. Number one is Taskscaler, because
Mhm.
um, auto scaling is a feedback control system. It has emergent behavior. There's complicated stuff that happens. There's even bugs now that I don't really understand why they're happening. So we want to sort of assert some things about the overall behavior of the system. First and foremost, stable behavior. Stable load provides stable behavior. Um,
Yeah, that's
the
related
most,
to the that recent bug we discussed, right?
yeah,
Yeah.
yeah, I did. I found a bug where, like, I tried to, set it so that it would always have two VMs or two instances. And there was no reason to delete any of them, but sometimes we are. And so we'll have an integration test for this. This would be providing the dummy plugin. So there's a static plugin, which is a static list of remote hosts. The dummy plugin is just one I think Aaron created, which just, I think you could just like tell it what to give you back. We can modify it, but like it'd be like literally like a mock or not a
Okay.
mock, a fake. It'd be like a fake
Yeah.
plugin, you know.
Gotcha.
Yeah. And so we'll tell it, it might model it just in memory, and we'll just start runner itself and start that dummy plugin. And then we can do, we probably will still want to have it register to a GitLab instance and still want to run actual jobs through that. But that part's not very flaky. And so it should be fairly easy to have a pretty like set these up pretty consistently. For scaling up, so I've actually written a number of auto scaling integration tests, and they're easy to write very badly. Because like you'll get a flake and it's like you're supposed to have 7 but I have 6, and it's like, do I need to be worried about this? I don't know. Like, we do have unit tests to verify like some of the very specific behaviors. So when I talk scale up, I'm talking about like I have 2, my parameters allow me to scale to 10. I create a crap load of jobs and I go up from 2. That's sufficient to say that everything's wired up so that we respond to load in the appropriate way. Same thing with scale down, verify, we get off 2, but we'll come back. So it's possible to combine these all into one, where you scale up and then you scale down and then you can scale up again. Kind of, gives you like a ladder proof of like, you could do this thing. So again, kind of hello world, like it's just be a lot of hello worlds at the right time.
Right.
That's basically it. Yeah, the complexity here is the timing, because you just want to know how long you should wait for the test to lift, how long you should wait for it to idle. But we can choose fairly aggressive times, like a idle period of like 2 minutes or something.
Yeah, that's probably a good idea. And all of this using the fake plugin that Aaron. Okay.
So I don't even need grit. There's nothing to set up. You could just run it. You could run these anywhere. You could run these on your local machine. And we should, maybe we even should run these as part of like the pre-submit pipeline.
Yeah, that would make sense.
And then we have integration tests for the other executors, but not for these new ones. So I think we should create those.
Yeah, I was looking at the docs for both of those. The instance, is that more specific? Because it mentioned nesting. So is the instance executor more specific to just our Mac?
Not really.
Yeah, the name was generic enough. I thought surely it means to apply to more, but I know that the nesting right now it seemed to only be a Mac situation.
Yeah. I want to show you a slide that I created. So the way that the executor used to determine everything is like this, shell was like, you just do it here. Kubernetes, you create do all this, et cetera, et cetera. But there's a number of different like pieces that can be managed separately. We're going more this direction, where auto scaling is handled by Taskscaler, isolation is handled by nesting. You have these different plugins, and you can take any path through here. And then once you find yourself, in a cloud provider, in an instance, maybe in a VM, doesn't matter, right? Like however you got there, like somebody's managing this capacity, you're inside. Then the only question is, what do you do now?
Right.
If it's instance, you just do the thing, run the script, right? If it's Docker, autoscaler, you start a Docker container and run the script in there. So you can actually, with the instant, we are using the instance executor with Mac, however, you can also use the instance executor with the AWS plugin without any kind of nested virtualization, and you can use Windows, and you can now have auto-scaled shell on Windows in AWS.
Okay.
So this is how we get auto scaling to all the things. Like we have a customer who's been testing the AWS plugin with us, and they use it for exactly that. They auto scale Windows tests in AWS, and they run shell scripts. They don't necessarily run a Docker container. So instance meaning you have an instance.
Right.
So,
right.
I don't know.
Well,
So yeah, these and actually if these two these two executors are very, very small. I think instance is maybe like 200 or 300 lines. Docker Autoscaler is like 30 lines because, for example, with Docker Autoscaler, all it's doing is it's actually taking the existing Docker Autoscaler, or sorry, the existing Docker executor, which it does have a lot of stuff that it has to do. It just takes that and it just wraps it in another executor provider that just says, okay, when I call prepare, it will call that outer shell, which uses Taskscaler to sort of find an environment to do the actual thing and create them as necessary. And then it goes into that environment, provides a connection to it, and then it calls that inner executor, which is Docker. And so then it has a connection already to a machine where it does Docker. So if you just like look at the code for those, they just wrap it in an autoscaler. Same thing with instance. It was the way that we were able to shim these in.
Now, you mentioned Taskscalers, getting that set up, but that is Taskscaler using the plugin to get the target.
So
okay.
What it looks like is as you go through, is like GitLab starts up, and it has a runner. As a matter of fact, let me actually show you. I wonder if I can. I don't think I have one usually available, but the config will have like the instance you want to connect to, and then it'll have a list of runners, and one of those runners it'll have a token, it'll have an endpoint, I think, and then it'll have some parameters. One of them is autoscaler, and inside autoscaler there's what's called a plugin config, there's a connector config, and then there's autoscaler policies. So when you're using the autoscaler section, you at the top level of that runner, you need to say the plugin name, which is the name of the binary to start. And then those parameters in the plugin config get passed through to the plugin, so you can tell it like what instance group, in what region, where can you find the key files, etc. The connector config is a more structured one, which tells you, should I use a public IP or a private IP? What username, what key file should I use to SSH to that machine once I get it? Okay, so runner starts up and it reads all this. And the first thing that runner does is it creates the Fleeting plugin that you asked for. It's like, okay, so I have a Fleeting plugin. And then it creates a Taskscaler. And for the Taskscaler, it gives it a couple parameters like those autoscaler policies, meaning at this hour of the day, please have this many idle instances. It's just all the autoscaling stuff.
Right.
And it gives that instantiated plugin to the Taskscaler, so that when the Taskscaler decides, I need to scale up, it just turns around and calls this interface, give me more. It doesn't really know what's inside the plugin, because it's just one consistent interface. It could go anywhere. So when I say starting a Taskscaler, there's one Taskscaler that's started for that whole executor, one Fleeting plugin, and it's all based on the config.yaml that you give the runner. So after that point, then you're just, when you pick up a job from that, it has already the executive provider, and it calls, prepare and then run and then clean up. Does that answer a question?
Yeah. It was just making sure on terminology, because we wrap things, because Taskscaler initiates a lot of these things. The plugin might actually interface with the cloud to actually get this set up, but we said the Taskscaler did it. So I was just making sure, terminology wise, we clarified that.
I guess it's dependency injection.
Yeah, they're very good. Now, so we've recently had some discussions too about our nomenclature for runner and runner manager. So would you say this runner that has Taskscaler and a plugin, this is a runner manager? That's how we get this
Yes.
set up? Yeah.
Yes.
And then the runner, we refer to that as just using the runner executable to execute whatever job parameters we give it. Right. So, and that's
Um,
on, and that would be set up down through the line with whatever plugin we're using.
that's right. That's the remote machine. And specifically what it needs is a runner helper or
Mhm.
something that can do the like the subset of like cache, artifact, git, pull, LFS kind of stuff.
Mhm.
But yeah, yeah. When you're running locally, it like calls out to runner. It's calls back to runner, which is kind of weird. But yeah.
Gotcha. Okay. Yeah, just because we're doing this for a wider audience. Sorry, I've injected some things
That's
like
great. That's
that.
great. I think that's a good thing to add.
Yeah, this is great. This is fantastic. I see some things. Looking through especially the end to end items. First question on that one though, because that would kind of be my focus coming from a QE perspective.
Mhm.
Um, if I can reuse what we already have, which is our quality framework, I can drive a lot of these things through our through GitLab itself using some
Mhm.
GUI automation that we have set up. That's all Selenium based. Would it make sense to? I know we had recent discussions with Toonie about trying to give more focus to the Kubernetes executor, but from a customer perspective, um, it seems like EC2 was more of a primary target initially for customers who are, and I'm thinking of customers who are setting up their own standalone runners. Where are they instantiating them? Are they
Mhm.
putting them in AWS? Is that where we want to focus?
Yeah. So one simplifying decision that I made in writing this test plan was that I just was having the various places you could install a runner manager in Google would
Hmm.
also run the jobs in Google. And the various places you could install them in AWS would also run them in AWS. So the actual runners would probably could just be like the same instance group that you use from Kubernetes and you use from a VM. You know it. So it is possible to have runner managers in Google and runners in AWS, which is what we do for Mac.
Hmm.
But then you need to set up a VPN tunnel, and I don't feel
Right.
like that's a pretty niche use case.
Hmm.
So I was trying to keep it in the same cloud.
Hmm. That
Um,
makes sense. Yeah.
yeah, yeah, because these plugins here, like these runner inset tests
Hmm.
do test the plugin, and so we can actually test like plugins that do different things. Like connecting to GCE, connecting to like a Kubernetes plugin. We don't really need to like make at the end-to-end test level. We don't need to make the plugin interesting.
Hmm.
Just where the runner manager should be interesting and unique
Hmm.
with each test. Yeah. Now you mentioned Selenium, and I was wondering if in your current framework, if you have a place where it would be natural to call Terraform to set this up for you.
No. No, yeah, where I was starting with this with runner staging was I was literally going to basically run daily jobs with a few specifications in them. And so have a scheduled pipeline and just instantiate the Terraform to get this set up within that pipeline and not from our GUI. And then within that pipeline, after that's set up, after I've verified it's up and running,
Mhm.
then I would instantiate the actual GitLab QA plugin to execute our gem. I mean to execute our GUI test there.
Okay. Okay. Um, Yeah,
and
I
then
was
and then tear it down after the fact.
okay, cool. Yeah, yeah, yeah. I mean, like you could just add a job on either side of the pipeline, right?
Right.
The setup and the tear down. Yeah, that makes sense. So, one thing that Georgie brought up during our discussion yesterday in the runners was about various like, so there's two actual points that aren't captured here, but if he doesn't write them, I'll write them into this issue, and I need to address them in the test plan. Number one, we should probably have some combination of long running environments as well as ephemeral hermetic environments. Like it's
Mm-hmm.
it's really nice for isolation, scalability, and reproducibility to do the whole setup, test, and then the whole teardown because it just works
Mm-hmm.
every time. But you do miss a set of failure modes that show up after running for a long time. And Georgie mentioned like filling up your disk. So we
Yeah.
might actually have one end-to-end test that continues to run hello world against an existing cluster. To make it easy on ourselves, we could
Mm-hmm.
like, I don't know. Well, yeah, like it should still be set up programmatically so you don't have something that nobody knows how to fix,
Mm-hmm.
but it should be there between tests. Like it should be running for several years, right? Ultimately. Um,
Yeah, that's definitely something you want to look at from a test perspective, and since auto scaling is based on time, right? We're constantly looking at the time. There are lots of time kind of situations that we want to consider. Timeouts. Is there any issues with time zones? Are there any issues with
oh yeah.
who knows, leap days? I mean, it could be anything along those lines, and a lot of those are definitely edge cases for sure. But
Yeah, yeah.
but you know. What kinds of things could impact that from a time perspective? And I think probably the most important is how long it's been running. So,
Yeah.
um, yeah, I think we can definitely get something set up
Cool.
that's long running. We just have to figure out how to minimize costs as best as possible for that.
Yeah, yeah. Cool. I mean, it could be basically the same test, just without the setup and the teardown step.
Right,
Or could
right.
it be it could be a Terraform plan, and then the test would fail if the plan has anything that it would change. In other words, it asserts that the environment that it expects is there,
Mm-hmm.
but it should already be there.
Right.
No teardown step, just like a assert plan step.
Yeah.
Um,
Yeah, we could definitely do that. And just setting up the long running environment, we would just set up a scheduled job to execute tests against it every so often, however often we want to do that, every 2 hours,
mhm,
4 hours, 6 hours, daily, whatever, weekly,
yeah.
whatever it is, to
Mhm.
to ping this infrastructure, and then we just, yeah, I guess see how it operates long term. So that one we can easily do just by having the test target a specific tag. We tag this runner that we get installed.
Yeah.
So that one can be set up wherever it is, and when we execute the test, if it's registered against whatever instance we're executing the tests on. And I'm targeting staging ref for a lot of these. Staging ref is a reference architecture environment that was set up using Get, um, and it's part of our whole end-to-end test pipelines
Okay.
that we go through. Um, anyway, it's an easy one because we have more access to that environment and
Good.
how
Okay.
GitLab is set up. So I can set these up as um, instance runners or group or project, however we want to do that.
Super. There's another thing that Georgie brought up, which was as far as setting up a Kubernetes cluster, there's a lot of different ways to do that too. There's just build Kubernetes from
Yeah.
first principles, put it on VMs, and then everything all the way to autopilot. So we probably want to kind of pick the most important ones. So actually, you asked this. You also were asking like, what do people do? Um, we probably should have a priority list of which of these to do first.
Right. Right.
And
That's basically
I,
what I was asking. Right.
yeah, I don't know. I mean, I have an intuition, but I think we should ask our product managers, Darren and Gabriel, which ones are the most important use cases.
Mhm.
For example, I know that Docker machine is heavily used. The Docker executor is I think our most mature and popular executor.
Mhm.
Um, but like also we kind of do want to get around to getting some testing in place for Kubernetes.
Right. Right.
So like we probably definitely want some of these are less important because we're dogfooding them, like the instance executor. Like I'll know if something goes wrong if it's involved in the max, runner stack. So
Mhm.
yeah, let's.
Yeah, my
So
initial discussions with Darren on those
mhm.
did kind of target AWS.
Okay, that's good
So
because
that
we also run most of our infrastructure in Google. So the more we kind of do something new and different, the better.
right, right.
Um,
So yeah, all of our SaaS stuff that we're testing, it's all Google related. So
mhm.
of course, except for Max, which is a hybrid.
Yeah.
Okay. All right. Excellent.
So I think
Um,
from here, next steps. Um, just kind of like capture any additional thoughts and requirements here. Like I had those things that I mentioned I wanted to write down.
mhm.
Make a priority list. Would you propose that a priority list of what you'd like to create, or should I?
I can do it.
Okay, cool. Yeah, just like a real quick just list in here. Ping Darren and me and Gabriel and just say, hey, this is the order that I want to do them in, and let's just pick the first one and go. Um, Whatever you choose, I can write the grit templates for it.
Okay.
Um, I'll have you review them, or if you're excited about it, then you can do it.
I'm
Um,
I'm I'm very excited about it. I need to dip my toes to make sure
or I
I'm
could do
following.
the first one and you could do the second one. I mean, like, this is a case where like I'm trying to like bootstrap this like common project, and so
Mhm.
I we're gonna have to like contribute some parts of this. So, and I'm still figuring out the structure. Like, I know
Mhm.
that I want this thing to be parameterized around a very complex decision tree about like
Mhm.
dev, test, production, blue, green, or non-HA. Like this,
Mhm.
the decision tree is going to be quite complex, and I don't yet know exactly how to structure it to keep it under control. So it's
Hmm.
these first couple grit templates are going to be ambiguous, which is not helpful when you're trying to do something other than that. You
Well,
just want to
it's
get a
yeah,
test running. Yeah.
it's where we're figuring out how we want to do it, right?
Exactly. Yeah. So yeah,
Iteration.
so totes. Yeah. So I can write the first one and then we can go from there. So
Yeah.
just pick it, like do you want to set up runner on Kubernetes? Do you want to set up on GCE? Actually, no, it would be EKS, AKS. No, is that right? No, AKS is Azure. There
Uh,
doesn't AWS have two Kubernetes offerings?
um, yeah. Is there one that's more automatic? Well, there's
Oh,
hmm,
AWS Kubernetes
EKS
services.
is the only one that I've ever really looked at. Uh,
Yeah, I think EKS is a good place to start. There is, of course, Fargate, which we do have capabilities for, but
I think that's the other one I was thinking of.
uh,
But again, this is Kubernetes, which we do want to get into, but I don't know that it's the starting point for us. It might be more looking at Amazon EC2 and our Docker executor.
yeah, sure. Sounds good.
Okay, but I'll get that into into the test plan and ping you all and see what feedback we get.
Sounds good.
We'll get that figured out. All right, that all sounds fantastic. And I'd love to piggyback on whatever you do with the first run, just to make sure, because I want to contribute to this as much as I can.
Okay.
So if we could do another one of these in the future when we're
Sure. I'm happy to.
working on some of
Anytime.
these things.
Anytime.
All right, that's fantastic. I really appreciate it.
All righty, cool.